Any questions in the last session? Any doubts? Okay, fine. In last class, we did 7 segment display and LED interface. So now in this session, we will start with another topic. We have completed 7 segment common cathode, and I gave you the assignment to complete it with 7 segment common anode. Hope you completed it if you don't have any doubts. So now I'm going to start the next one. That is your IC4511. IC4511, which we used to convert BCD to 7 segment at the time of simulation. So I'm not going to include the description of that IC. That is why I told the simulation when starting. So now we have to focus upon programming only. So let's let's create a small circuit for 7 segment common cathode IC4511 and at mega 16. So I'm going to pick, let's pick at mega 16, and then we need IC4511, and we need 7 segment common cathode. Now let's connect all of them together. So in this 7 segment interface, I'm not directly connecting this 7 segment display with the controller, which we did yesterday, because now we are going to include IC4511. And there is one more benefit if we connect IC4511. The first benefit is that we are going to use only 4 pins of IC at mega 16. That means we saved other pins for any other task if we want to. And then after this, we have another benefit that I'll tell you during the program. So let's connect it. Port C0 to A, port C1 to B, port C2 to C, and port C3 to D. And then let's connect LT and BI. LT was lamp test and BI was bit inverse. So let's connect both of the pins to 5 volt. So I'm using a power source, a 5 volt source. And then we have to connect latch enable pin, which is basically active low pin with ground, so that if we give the logic 0, it must pass logic 1 to latch the path or to create the address a data bus, so that the logic from ABCD can travel to QA, QB, QC, QD, QE, QE, and QR. That means we are passing the logic of 4 pins to 7 pins through these pins. Now let's connect all these QA to A of your 7 segment, and then QB to B, QC, QD, QE, QF, and QG. Let's check, is it connected? Yeah, it's connected properly. And then the last pin, which is 7 segment common cathode, we need to connect to the ground. I told you this earlier as well, that if we suppose want to connect 7 segment common anode display and that with IC4511, then this feature is not available because this IC is not going to work with 7 segment common anode display. That is it. We are done with the simulation part, the circuit part. Let's create the code for this. So do remember we have used total 4 pins, port C0, port C1, port C2, and port C3. And these 4 pins we are using as output because we have to write the logic to A, B, C, D. And this IC4511 converts the BCD signal to 7 segment. That means we will be giving the logic into the form of 8421 through the pins PC3, PC2, PC1, PC0, so that it can pass to DCBA. DCBA 8421. Okay, let's start a project here. File and new and project. So I'm defining it as let me check how many files we have saved in this folder. So first, second, and P3. So it must be P4 now. So let's write the name of the project as P4, project 4. And then we need to select the IC, that is at Mega 16. So we can connect it in this way. Now we have to define the DDR and ports depending upon which number we want to print. So firstly, let's define the port C as output. And for that, we have DDR registers. So DDR-C equals to 0B, 11, 11, 11, 11. So that means we are using the whole port as output. So we declared it as output. Now after this, I'm working in while loop. Why I'm working in while loop? So that we can repeat the printing whatever we want to. Now first we have to write the code and we need to create the combinations. So for example, I'm just writing it here and then later I'll delete it, or otherwise let's write it in text document. So for example, here we have total 8 pins of port C, port C7, port C6, port C5, port C4, port C3, port C2, port, port C1, and port C0. Now we have 8 pins of this port. And now suppose if I'm connecting DCBA, so we have connected it in this way. Fourth till fourth, nothing is connected. And PC3 is connected with D, PC2 is connected with C, PC1 is connected with B, and PC0 is connected with A. Now, if we want to write the code in binary format, it must be 0, it must be 0, it must be 0, it must be 0. Now, let's choose what exactly we want to print. For example, we already know about it, that here we have 8 and then 4 and then 2 and then 1. So here let's write the code 8421 DCBA, and we have to print suppose 1. So how to write 1? 0, 0, 0, and 1. Now if suppose we want to write, let me also do one thing. Let me comment it that we are writing 1 here. So 0001 is the code for 1. 0001 is the code for 1. And now let's write it for 2. So 0, 0. These 4 pins are always 0 now because we haven't connected anything here. But DCBA has important role for all the numbers. Now as we have to print 2, it must be 0010. So 8 is 0, 4 is 0, 2 is 1, and 1 is 0. That means 0 plus 0 plus 1, 0 plus 0 plus 2 plus 0 equals to 2. So we wrote this code for 2. Now I'll write the last number as 9. So for 9, it must be 8 plus 1. So let's turn on both the pins PC3 and PC0, where we have pin D, pin A, that means the logic 8, 4, 8 and 1. So 0, 0, 0, 0. And now this must be 1, this must be 0, this must be 0, and this must be 1. And then here we can say it's the code for 9. So now let's write the same thing here. Okay. So in port C, I wanted to write 1. So port C equals to 0B, 0, 0, 0, 0, 0, 0, 0, 1. And then let's write the code for the next number, that is 2. So port C equals to 0B, 0, 0, 0, 0, 0, 0, 1, 0. And now let's write the code for 3. So it must be port C equals to 0, B, 0, 0, 0, 0, 0, 0, 1, 1. 2 plus 1 is 3. And finally, we are writing the code for 9. So port C equals to 0, B, 0, 0, 0, 0, 0. Now 8 plus 1, that means 1. That means 1. 0, 0, 1. So this is the code for 9. Now we need to do one more thing. We just write the code for numbers like 1. Let me comment it as well. 1. And the next we wrote this for 2. And then next is for 3. And then next is for 9. But we haven't defined any delay here. So whenever we will be starting this code, what exactly it will do, it will not print 1, 2, 3. It will directly print 9. Because it know after 1 it has to print 2 without any delay, after 2 it has to print 3 without any delay, and after 3 it has to print 9 after delay. So it will write the last code. Although it's writing all the codes like 1, 2, 3, 9, but we are not able to see because there is no wait time. So it's quickly changing the process from 1 to 2, 2 to 3, and 3 to 9. And why we can only see 3? Because that is at last. So what we can do, if we want to write each and every number, we want to print each and every number, we just wrote here in the code, we need to add the delay. So underscore delay underscore ms is the function which we already know. So let's write a delay of 1000. That means 1 second. And now same way, let's write delay here. In same way, let's write delay here. And now at last, let's write the delay. Then let's come back here. We can see it's a delay of 1 second, 1 second, 1 second, and 1 second. So let's build the code and check, is it working? And if it's working, then we will try to change this code to something else. But okay, fine. So there is error because we haven't used the header file. So hash include util slash delay dot h. Okay, now finally let's build it, and we got the hex file successfully. One succeeded. Let's go here, double click and browse, and the code is in desktop D4, and let's click OK. So now we can see it's printing 1, then 2, then 3, and then 9. 1, 2, 3, 9. It's in while loop, so it will repeat the process. Any doubts, anyone? Okay. If no doubts, we can start the next one. See what we can do here. As I said, if we use 4511, there are two benefits. The first benefit was to reduce the number of pins of your controller. And I told you, second, I'll tell you when we will be doing the programming. So now we are completed with programming. We almost wrote the whole code for 1, 2, 3, 9. And now this is your assignment to add for more numbers like 4, 5, 6, 7, 8. Okay. And 0 as well. But I'll tell you how we can change this programming to create a difference. Why we using this IC 4511. So you know we have two methods to write the code. The first method is 0b, which basically indicates the binary logic. We have total two methods to to write your logic. Right, like the first logic is 0b in binary, and the second logic is in 0x, which is basically hexadecimal. Hexadecimal. So we can simply write the hex code. You know, this code one is for in the form of binary, and we are writing it for one, and we are creating that code after seeing 8421, and we know that an 8421 already the hex number. Then what is the need to convert? Like when we have to print 1, we can simply write 1. When we have to print 2, we can simply write 2. We are not required to change that code to the binary one if we start writing the code in hexadecimal. Because if we convert this one, this is what? This is 0, pair of 4, 0, 8421 is 0. And then here it is 8421 again, but it's 1. So the simple code for this is 0, 1. And if I convert this one as well, so it will become 0, 2. You can check, you can cross check it. Like this one is 0, and then this we wrote for 2. And in the same way, this is 0, and this one is 8 plus 1, 9. That means what I want to say, whenever we have to write any number, And if we use the binary logics, then we need to create the combinations. We need to create the combinations. But if we use the hexadecimal, we not need to create any combination. Whatever number you want to print, you can simply write it in the code. So let's do the same thing now. So what I'm doing, I will be using 0x01 in the place of 0b00000001. So let's write 0x01, and then suppose if I want to print 2, then we have to change it to 0x02, and for 3, let's change it to 0x03, and then 0x04. Oh, sorry, it was for 9, so 0x09. So whenever you want to write for 7, you have to simply write it 0x07, and for 8, it must be 0x08. Okay, let's run this code. I'm adding one more code here. Either I'm changing this one 9 to 7 so that we can feel the difference because we changed the code here. Otherwise, the controller already has your code, which was in the binary logic, and already it's running the same code, and we are getting the output 1 to 4, 1 to 9. But now I just ask the code to write 1, 2, 3, and then 9. Not 9, 7. So 0b, not 0b, it must be 0x only, and then 07. Okay, fine. Let's build it now. Let's stop it and let's play it. So now we can see it's doing the same thing as it did earlier with your 7 segment displays, 4511 and binary logics. So if you have any questions, you can ask me. Fine. Then let's do the next one. This is your P5. And let's write the name of IC as 16. So it's at Mega 16. And now let's go to the design and save this design so that we can easily start the next topic. Okay. So now the next topic is button interface or sensor interfacing. Our next topic is button interfacing or sensor interfacing. So we know, like when we ask this LED to turn on, or when we ask multiple LEDs to turn on and off, and also we know we created a program for blink. So whenever we did this, we simply turned on all of them. Like whenever we go to the play button, those all LEDs were on automatically. Now suppose if I want to put a control on that, like when I want, then it must be on, and when I want, it must be off. So for that purpose, we can simply use the sensor interface or the button interface, because now your output is dependent upon the input. So for example, if we have a sensor and a motor, and we want it like when sensor is on, motor must be on, and when the sensor is off, the motor must be off. That time we can use button interface or sensor interface. So let's write the topic name, sensor interfacing slash button interfacing. So I'm going to delete the whole code, file new design. Let's pick at Mega 16. And then let's use one button for sensor, and then one LED. That is it for now at Mega 16, and button and LED yellow. Now let's connect this LED yellow positive to port C0 and negative to ground. Now we have two terminals on this button. So when I'm connecting with port A0, which is pin number 40, and here we have one more pin which we need to connect somewhere. Now suppose if I connect it with ground, it's not going to work because in this case the pin PA0 must be input. Why it must be input? Because this time the sensor is going to sense something and accordingly it will give the logic to port A0. That means this pin is going to behave as input. So the direction of current must be inward to controller. The direction of current must be inward to controller. So if we say like the port A0 is input and the button is providing the current to this pin, but how the button is providing this logic 1 or the current? Because button does not even have the power source connected to it. So we know whenever we connect sensors or buttons, the one end must be connected with the power source, not the ground one. So we are not allowed to use this for now. We will be using power. So now this button has a power and whenever you keep it on, it will pass the 5 volt to PA0. And if PA0 receives the logic 1, according to your program, it will turn on the motor. And if the sensor is not turned on, if the sensor is off, it will give the logic 0. And according to logic 0, the LED must be turned or the motor must be turned off. So why I just explained this thing because we have to use the power symbol with button and the pin number A0 is going to receive the logic. So your button must have a source so that it can provide the logic easily to port A0. Now you know why what exactly we have to use in this programming, because we have a button, right? So if we have a button, there are two conditions. If we have a sensor, there are two different conditions. The one is if the button is on and the second is if the button is off. So whenever we have conditions, that time I told you we have to use if else. We have to use if else. So if else are known as conditional loops. So if the button is on, the motor or the LED must be on. If the button is off, the motor or LED must be on. So two conditions are there, on and off, and accordingly the output is also on and off. So we have to compare, and also we need to declare this port as input and this port as output. So let's start writing the code. Int main and DDR A equals to, let me see, yeah, A. So DDR A equals to 0B, 00, 00, 00, 00. That means we defined all the pins as input. Now, next is your DDR C, where we connected the LED. So that complete port must be output. So 0B, 11, 11, 11, 11. Then after this, let's come to the while loop. So here we have to compare. Here we have to compare that if the button is on, the LED must be on. If is here. So how to write the if syntax in this AVR coding? Simply if and then write your condition, whatever it is. And after that, start the curly bracket and write your statement inside the loop and terminate the line and close the braces. So this is the whole loop for if condition. And now suppose if we have two conditions, we have two different ways. The first is simply write else statement and close the bracket. So if we use the else, we not need to define the second condition. But suppose if you want to define the condition, you will have to use else if, and here we also need to mention the condition too. So in this example, when we have to turn on the button on behalf of sensor input, we can say the condition 1 is button on and the condition 2 is button off. And what are two different statements? The first statement is LED on and the second statement is LED off. So if you want to write the condition, the second condition, then you must use else if. And if you don't want to write any second condition, you can simply conclude with else only. But somewhere, suppose if you have more than two conditions, 3 or 4 or 5 or 6, then you will have to use else if, because there the else is not going to work. Okay. Now this was the syntax. So we have to now write the actual code. And to write the actual code, we also need to understand one more thing here, that is how to compare the conditions here. How to compare the conditions here. According to the programming, if I write a equals to 5, that means we are assigning the value of a to 5. And if we write a equals to 5, that means we are comparing, or we are asking that is a equals to 5. But here, when we have to turn on the button, what exactly we have to compare? What exactly the condition must be? We have to identify that thing. And if we are able to identify that thing, then we can definitely work with the project, work with this problem easily. So now let's delete this. We understood about double equals to. So what I'm going to write, int x equals to pin C, pin A, and 0b 000001. So now why I'm doing this, to understand that, first of all, let's write the first condition, the button is on. So according to us, we have to compare this in this way. Port A equals to 0b, not equals to, it must be double equals to 0b 00000001. That means we are saying if the button is on, which is connected with port A0, then we have to write the statement LED on. And in second condition, where we have else if, we need to write port A equals to 0b 000000. So this is the whole code which exactly we have to write here, but there are few changes which is compulsory. And what are those changes? To need to understand those changes, we need to take one example. So we are comparing in first condition 000001. That means the button is on. But what if port A hold any old logic? I'm repeating my words. I said, what if any pin of port A hold any old logic? Let's consider if PA1 has the logic 1, or PA5 has the logic 1, or PA7 has the logic 1. So let's start it from PA7. So suppose if PA7 has the logic 1, then complete port A is equals to, the port A is equals to 0B 1 0 0 0 0 0 1 sec 1 0 0 0 0 0 0 1. So this we turned on. The button of the sensor we turned on. But as I said, if there is any logic on any other pin with the logic which is with the last program or with old practice, then it the code of port C will be like this 10000001. But actually we are comparing something else here. We are comparing if port A equals to 0B 00000001. That means we are saying only one pin is high. Only one pin is high. That is port A0. That means only the button or the sensor is turned on. So according to the statement, we have to simply turn on the LED. We can write this code very easily because we write it many times now. Port C equals to 0B 00000001. So we just wrote the code to turn on the LED. But what I was saying is very important. I said if port A7 already holds the logic and we turn on the first button, the logic in port A will be this one 0B 100000001. But what we are comparing, is this equals to this one? No, because this we are writing that all other pins of port A are 0 except port A. All the pins of port A are 0 except port A 0 pin. So it's not going to satisfy. That is why. If any of the pin of your port holds the previous logic, if any of the pin of your port holds the previous logic, we need to make it 0. And for that only we have this command x equals to pin A and 0B, 00, 00, and then again 0001. So what exactly we are doing in this command? We are asking we are asking the pins of port A to multiply logically with this code 00000001. This will do, you know what? We have AND gate, and whenever we multiply any pin with 0, it gives you 0 output. That means if any of the pin of port A except port A0 holds the previous logic, you can make it 0 simply by multiplying or simply by masking. This process is known as the masking process. This process is known as the masking process. Now, we made the whole port as 0 except port A0 pin. And why we didn't made this pin 0 as well? Because this pin depends upon button. If it is on, it will be on. If button is off, then it will be off. So X is undefined here. Whatever we multiplied, we just stored the result in the variable X. But X is not any predefined letter, any predefined word here. So let's define integer class for X. Now we can easily compare it. Now we can easily compare it. If you give the logic 1 through button, that means you are turning on the button. This code is going to be there. And same way we are considering here, if x equals to 0b 00 00 00 01. If your x is equals to this code, that means the first button is on, then turn on the LED. And second condition, else if the x is equals to 0b 00 00 00 00. This time the button is off, and we are comparing the same thing. If the button is off, then run the statement 2. So whatever we are multiplying with this 7 pins of port A, it will make the multiplication factor as 0. If it holds any previous logic, after masking, it's going to be 0 only. Now, this was the suitable way to solve this problem. Also, I'm going to add one last code here, which is for this, where I'm going to build 0, and let's now build it. Now, if we double click on this controller and if we browse it, we need to identify our folder, which is now P5. So the project name is P5 and hex file is already there, created on 10:35 p.m. Let's select it. Let's click OK. Let's click play. And now we are able to see, if we turn on the button, the LED is on. But if I release this button, because you know this is direct button and I am holding it. This is the direct button and I am holding it. But what if I release this? If we release this, the LED must be on, but it's not on. Then again, we need to understand few more logics. Before we go ahead, do you have any questions or doubts? Okay, fine. So, what I said, the button is on, the LED is on, but when the button is off, the LED is not turned off. And why so? To understand this logic, we have to identify the colors as well. In this simulation, if it shows you red color, that means it's logic 1. If it shows you blue color, that means logic 0. And if it shows you null, that means there is no logic. It's called null. There is no logic. It's called null. So we can see on the right side of this button is gray logic, which we are passing to port A0. That means there is no logic at port A0. It's null. So that is why there is no condition which is satisfying, because we have only two logics in binary, the 1 and the 0. The 1 is on and 0 is off. So 0 is not coming here. And if 0 is not there, then definitely button or the sensor will not respond in a correct way. Let's do the same thing. Because the coding part is correct, we cannot change anything in the code to just rectify your simulation. Because code is absolutely fine here. We are doing masking, and then we are comparing. If the first button is on, the LED on. If the second button, if the first button is off, the LED is off. So what exactly we have to do now? Let's pick register. There is a motive behind picking this register. I'm connecting this to ground now. And then let's click play. We already know the current choose the shortest path to travel. The current choose the shortest path to travel. If we do not connect this register and connect this ground directly, and when we turn on the button, the logic one will travel from the source, and it's not going to put the efforts to reach port A0. It will directly come to the ground one and become 0. Current always choose the shortest path. It does not want to take any responsibility. That is why we cannot directly connect the ground here. If we connect, it's not going to give you the output. That was the reason why I connected this register, because we know current always choose the shortest path to travel and minimum resistance and minimum resistance. So we can compare it like your speed breaker on the road. Speed breakers on the roads are kind of resistance, and the current is your vehicle's speed. You are riding or you are driving your car or bike. So if you see speed breaker, obviously you are going to reduce the speed. In the same way, if current starts flowing through the register, definitely as an output, we will get less amount of current as compared to before register. So the solid and the strong reason connecting this register is what? If we turn on the button, the logic one will travel from here through button, and it now has two paths to travel. The one path is to reach pin number 40, port A0, and another path is to reach the ground one. So it's obvious the current is not going to take too much headache, because here it's register. So it will directly reach to the pin number 40. And if it reaches to pin number 40, this condition is going to be true. And if it is true, we can see the LEDs on. Now, if suppose we turned off the button. So we have a logic here at pin number 40, that was 1. Now 1 will start traveling. It has two paths to travel, the register path and this button path. Current always choose the shortest path, so it will try to move through register, but it has to find another path as well. Here it is button, but it's open circuit. So current has only one path to travel. So it will become ground this time. Now let's run and play. So it's on and it's off. It's on and it's off. So that is it for the day, guys. We will see the next one tomorrow. Till the time, keep practicing. And if you have any questions or doubts, you can ask me on WhatsApp. Thank you so much. Bye-bye. Good night.